Let us solve the ladder and box problem. In this case, we are given a ladder of 4 units in length and a box such that all the sides of the box measures 1 unit each. The obvious question is, what do you think is the height of the ladder above the box? Let's draw the figure once again. Let the height of the ladder above the box be equal to x unit. Once again, box is of 1 unit each and ladder is of 4 units each in length. Let y be the distance between the box and the base of the ladder. Then by trigonometry, tan theta equal to, let this angle be theta, then tan theta equal to x by 1 from this triangle, tan theta equal to x by 1. Again from this bigger triangle, tan theta equal to 1 by y. So from smaller triangle, tan theta equal to x by 1, and from bigger triangle, tan theta equal to 1 by y. So if we compare these two, we obtain x by 1 equal to 1 by y. We could have used property of similar triangle as well. X by 1 equal to 1 by y. These two triangles are similar and sides are proportional. So that gives us xy equal to 1 or y equal to 1 by x. Now let us apply Pythagoras theorem that says that base square plus perpendicular square equal to hypotenuse square. The ladder will act as hypotenuse. So by Pythagoras theorem, base square, base is y plus 1. So y plus 1 square, y plus 1 whole thing square, plus perpendicular square. Perpendicular square is x plus 1 whole thing square, plus x plus 1 whole thing square equal to hypotenuse square. Hypotenuse is just length of the ladder, so 4 unit equal to 4 square. Now y equal to 1 by x. So we can write this equation as 1 by x plus 1 whole thing square plus x plus 1 whole thing square equal to 16. Let's square it. We know the formula for a plus b whole thing square. That's equal to a square plus 2 into a into b plus b square. Once again, we know the formula for a plus b whole thing square. That's equal to a square plus 2 into a into b plus b square. That's equal to 16. Now, we see that we can write it a bit differently, x square and 1 by x square, and then 1 square plus 1 square is 2. Let's write it together, x square and 1 by x square and 2. So we wrote this 1, 2, 3, 4 different quantities clubbed together, and then 2 by x plus 2x, we write it separately. So we wrote 2 by x and 2x separately, rest of the expression separately, equal to 16 as it is. What's the advantage? You will see soon. If you expand x plus 1 by x whole thing square, then you will get x square plus 1 by x square plus 2 into x into 1 by x. So yes, that is, this expression is simply equal to x plus 1 by x whole thing square. But what about this one? If you take 2 common, then you get x plus 1 by x. Let's write the 16 to the other side. So minus 16 equal to 0. Now you see that something square plus 2 times something minus 16 equal to 0. That reminds us about quadratic equation. Let y equal to x plus 1 by x. That implies y square plus 2y minus 16 equal to 0. That's a quadratic equation. Let's write the standard form of quadratic equation. ay square plus by plus c equal to 0. Roots are given by y equal to minus b plus minus root over b square minus 4ac by 2a. And so y equal to minus b minus 2 plus minus root over b square 2 square minus 4 into a is 1 into c is minus 16 divided by 2 into a that's a is 1. That implies y equal to minus 2 plus minus root over 4 plus 4 into 16 divided by 2. We can take 4 common, so we can cancel. Square root of 4 is 2 and 2 can be cancelled. So we will be left to minus 1 plus minus root over 17. You see that y equal to, but y equal to x plus 1 by x. That implies x plus 1 by x equal to minus 1 plus minus root 17. But as we have assumed x to be a distance, therefore, but the distance must be a positive quantity. Therefore, minus 1 minus root 17 can be neglected. So we must have x plus 1 by x equal to minus 1 plus root 17. Now let's multiply by x throughout to obtain x square plus 1 equal to minus 1 plus root 17 times x. That can simply be written as x square minus of minus 1 plus root 17 times x plus 1 equal to 0. Once again, this is a quadratic equation. So roots are given by x equal to minus b. So minus of this quantity is root 17 minus 1 plus minus root over b square. So root 17 minus 1 whole square minus 4 into a into c. 4 into 1 divided by 2 into a is 1. That's equal to root 17 minus 1 plus minus root over root 17 is, we apply the formula a minus b whole thing square. Root 17 square is 17. 1 square is 1 minus 2 into root 17 minus 4 divided by 2. That's equal to root 17 minus 1 plus minus root over 17 plus 1 is 18. 18 minus 4 is 14. So 14 minus 2 into root 17 by 2. Therefore, we have determined the required distance. If you want, you can determine those values approximately, and it's equal to, if you want, you can determine these values approximately and you will get 0.362 or 2.76.